Is it fine? You are understanding this? This spectrum is very important, right? This is what you see is the spectrum of EM. Okay. Now, have you understood how to see this spectrum? You are not able to see the board? Sorry. Because this thing has come in the center.
Sir, on the negative side also we'll have the upper sideband and the lower sideband frequency.
Sorry, this is FC minus FM. Sorry, this is FC minus FM. Is it clear about the spectrum of EM wave? Is it fine? Okay. Now, let us try to do it in Simulink. Okay. Okay. Before that, I'll just like to continue do one small thing. See, this is okay for you, right? Spectrum is okay. Spectrum is very important. You need to know spectrum of any transmitted waveform. This is the spectrum of the transmitted waveform once you do the amplitude modulation of the message signal. Fine? Okay. So now you can see when the modulated wave is transmitted, now it has multiple frequencies. Yes or no? Right? See, the simple amplitude modulation which you have seen now from the equation and from the fundamental concept of amplitude modulation. How we got this equation? From the fundamentals, right? What fundamentals? And you just have, you know that amplitude of the carrier wave is varied according to the instantaneous value of the message signal. Using that concept, you got this equation. Using that concept, you got this equation. Yes or no? Right? This is what you have done. Hope all of you understood this derivation. It's very important. Okay. You got an equation. Yes, AM of t is equal to AC cos omega ct, MAC by 2 cos omega c plus omega mt plus cos omega c minus omega m into t. And next one is just the Fourier transform of that equation. Fine. Okay. Now, what you got? You got now 3 frequency components in this. You have carrier frequency, you have upper sideband, you have lower sideband. Now, question is, do we require all these frequency components? Do we require these frequency components? Okay. We don't require. Right. The carrier, you are also sending a carrier wave. Can you see here? AC cos omega ct. Do you require cos omega ct? No. Okay, you don't require cos omega ct. Right. Now, you have omega c plus omega mt or omega c minus omega mt. Do you require 2 sidebands? 1 sideband is enough. Right. So, this is called as conventional AM wave. What you got now is called as conventional AM wave. This is called as conventional AM wave, which has a carrier frequency in it, which is very clear from the equation and the plot you have, and it has a upper sideband and it also has a lower sideband. Okay, so we need to remove this. Remove either 2 components out of this, keep only 1, right? You need to remove these 2 components, keep only 1 sideband. Okay, carrier anyway not required. Carrier anyway, it is not required. Okay, so what is done? We have another technique, simple modulation scheme, which is called as, see, double sideband suppressed carrier. We have another scheme which is called as double sideband suppressed carrier. Right? What is the meaning of this double sideband suppressed carrier? In this double sideband suppressed carrier, okay, AM wave, you will get 2 sidebands but no carrier. You will get 2 sidebands but no carrier. Okay, how do we generate this double sideband suppressed carrier? amplitude modulated wave. It's very simple because I don't have any slides for this. You yourself can do understand it. Okay. Now, sorry, I don't have the. Let me check here. Okay, yes, okay. How do you get double sideband suppressed carrier wave? Okay. Have you understood what is double sideband suppressed carrier? In double sideband suppressed carrier AM wave, you will not get carrier wave at all, but two sidebands will be there. Okay. How do you get it? Very simple. Let m of t is equal to am cos of omega mt. Okay, fine. Let c of t is equal to ac cos omega c into t. Right? Okay. Now you have to, you all of you know trigonometry, right? Right. Okay. Fine. See how you generate double sideband suppressed carrier waveform is very simple. Okay. You just have to multiply this m of t and c of t. Okay. You just have to multiply m of t and c of t. Right. Okay. Now, so what you will get here? You will get here AC into AM cos of omega mt, okay, into cos of omega ct. Can you get me the expression? Suppose if I just write this as S D S B S C of t. Can you get me expression for S D S B S C of t? Get me this expression. Can you get me this expression? What you will get? Tell me. What is cos A cos B? I don't know. Okay. Tell me. Half is there, na? No. Cos of A plus B by 2 minus or plus? Plus, huh? Then formula for your help. Whole divided by 2 is there, no? It's not there. Yes, of course. Yes. This will be half, huh? Yeah. So what you will get actually? This is not there, no? Not there. Yeah, yeah. That's right. This is correct. That's not there. Okay. So those who are online, please correct this. Okay. So hope you are all able to understand. Can you just give me your feedback? Those who are in online, can you just give me a feedback? Say that you're all okay, or you're all
Yes,
there,
sir.
not sleeping. Hmm?
Yes, sir. We are here.
Yes, good, 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 good. Okay.
Sir,
So I'm also
sir,
having
what does
earphone. You can just call me.
EM?
Okay, unmute and remind. Okay, Fine.
Sir,
Good.
sir, I have a question. So what does DSBSC mean?
Okay, what do you get? Tell me.
Double sideband, and
Hmm?
I missed the last two terms.
AC, AC, AM by 2 into cos of FC plus FM, right? Plus cos of FC minus FM. Now, can you please draw the spectrum for this? Can you write the equation? What is the Fourier transform pair of this? You know, right? What is the Fourier transform pair of this? You know. Can you write the spectrum now? Can you write capital S DSB SC of omega? So, what is the spectrum of this? Pi into delta. Now it is F. Sorry. Now it is F. F means pi will not come there, right? Pi by 2, 1 by 2 will come. Yes or no? Right? If you are writing this in terms of F, okay, then earlier you wrote pi, right? For that you have to divide by 2 pi, right? That is become 1 by 2, right? So then you will have AC AM by 4, right? 4, okay, then delta, come on, F minus FC plus FM plus delta F plus FC plus FM. Then is it over? Then this one, right? I'm just taking ACM by 2 by 4 outside. Okay, so this will be having half delta, right? This also half delta. I'm just taking outside. I'm writing it as AC by AM by 4 outside. Right. Now, then what else?
So we have pi
Plus
also there.
delta F minus FC minus FC minus FM plus delta F plus FC minus FM. This is a spectrum. Okay, see, if you know Fourier transform pair, how easily you can find out the Fourier transform. Okay, can you plot this? Can you plot this? It's the same plot. It's the same plot. But what is not there? What is not there? Carrier is not there, right? It's the same plot. Okay, same plot. It's the same plot. See here, same plot. So you will have FC plus FM, FC minus FM. Okay, what is the amplitude? AC AM by 2. AC AM by 2. Okay, fine. Okay, now here this is FC minus FC plus FM. This is not there. Now, what did you understand from this? Sorry, I'm very sorry. This is right for it. Is it okay? If this formula is fine, this will be okay. Fine, okay? Just simple trigonometry, yes or
So
no?
won't the amplitude be ACM upon 4 pi?
Now, can you do it in Simulink? How do you do it in Simulink? Tell me, how do you simulate it in Simulink? This equation. Let us do the simple this one, okay? Okay, Simulink is very easy. Okay, Simulink is very easy. See, I have already opened here. Okay, see here. What you have to do if you want to invoke Simulink, just go to this MATLAB. Okay, those who are online, please try to do this. This is also a part of your lab book. Just put Simulink there, right? Okay, when you put Simulink, this one will open. This is called Simulink. In Simulink, you need not write any programs. It is just using blocks. Fine. Okay. Now see here. I want to do simple double sideband separate carrier. Same thing I want to do. Okay. So what you do? I already have one here. If you don't have any program, you can just click on the create blank model. Okay, just create, moment you just click on create blank model, one new model will be created. Fine, okay. And then you just have to add the blocks. I think I had told you about this in one of the class. Now I already have this DSP-SC or implemented using, see how do you implement DSP-SC here? What I did here, can you see here? To implement DSP-SC, what I did here, can you tell me? You have taken message signal, you have taken carrier signal, and you have just multiplied it. Just multiplied it. Okay. It's just loading now. Just wait for 1 or 2 minutes. So try to simulate, try to learn the simulink, which is very, very interesting, especially for engineers, right? Where you did not write any program. Okay. But it takes some time to load unless your RAM speed is very high, right? Okay. Even though I have 16 GB of RAM, it is taking time. Okay. See here, this is what you get. Okay. See what I did here. Can you see here? See, this is your message signal. Okay. So if you double click this, you will see its attributes. Okay. See here. Okay. Now see here. What is the frequency? See, amplitude I have taken as 5. Okay. And you can see here that frequency is radians per second. I have taken it as 628. Okay. So you have option to make it as 2 into pi into frequency. You have that option. Either you can write 2 star, pi star, whatever frequency. Okay. This is I think 100 hertz. Right? I have just multiplied 2 into 3.14 into 100. So I got this. Fine. Okay. So you just have to put the frequency here in 2 pi f. Now see here, phase you make it 0. Okay. And bias you make it 0. Now this one sample rate. What is sample rate? Okay. See, always try to make samples fine samples so that your curve will be smooth. If the samples are not fine, you will not get a smooth curve. It looks like a triangular way sometimes. That's why what I have taken here, I have taken sampling frequency as 10,000 hertz. 10,000 hertz means what's the sampling period? 1 divided by 10,000. It is 0.0001. Have you understood this? Okay. So here I have taken my frequency of the message signal as 100. Okay. Now, okay. Now double click on this. Okay. Now here, what is the frequency I have taken? 6280. That means I have taken 1000 hertz. Okay, 1 kilohertz. Carrier frequency. Your carrier frequency has to be very high. Okay, supposed to be megahertz. Okay, because what happens is when you make it megahertz, okay, you in MATLAB it will just look like a dense waveform. Okay, fine. Okay, I will show you that now. Okay. That's why I have taken frequency as 1000 hertz. Okay. Carrier frequency 100 hertz. Okay. Now, okay. Okay. And this is what? Multiply. See, all these things you can get it from here. Can you see here? This is called as block. See here, everything is there. See. Now, if you go to the sources, you can find all the blocks. Signal generator is there. Square wave you can generate. Anything you want to do, you can generate here. Okay. Have you understood this? Okay. Now sync is there. See, sync is scope is there. Okay. And display is there. Whatever you want, you can display. Fine. Okay. Now this is the scope. Okay. See, double click. Now see here, if you go to tools here, okay. Now somewhere you can just number of input port you can just change. You can have multiple input ports. Okay, accordingly you get the display. Okay. Now here I have taken 3, you get 3 displays. Okay. Now what I will do, this simulation time, you make it small. What happens if you make big simulation, long-term simulation, all waveform it will try to display in a small space. Okay. Now you see how do you get your waveform. right? Yeah, I think it's doing it. Okay, now simulation is done. Okay, it will say ready. Once it is done, ready. See, it will say ready here. Okay, now double click on this. See, can you see this waveform? The one you see in the top is the message signal. Okay, one you see in the top is the message signal, and the bottom one, middle one is carrier signal. And this is what your modulated signal is. This is what a modulated signal is. And what is this actually? Double sideband suppressed carrier wave. Double sideband suppressed carrier wave. Have you understood this? Okay. Now, how do you generate conventional EM wave now? You have the equation with you. Suppose if I ask you to generate the conventional EM wave, how do you generate a conventional EM wave? To the equation. You have AC cos omega CT, right? And then, come on. How do you generate conventional EM wave? See the equation.
We have upper and lower
You
sideband
just have to
frequency.
generate two signals. Okay, I will try to. Have you understood this? This is the way. This is called double sideband suppressed carrier wave. So what you see in the bottom is EM wave. Can you see the amplitude is varying with respect to message signal? Okay, and you see here, this will not have that carrier term. I understood this. That carrier term is not here, right? Okay. Now, before this, I would like to show you the waveform of conventional EM wave. See. This is conventional EM wave. Can you see here? Right? And you see here, this has got a carrier wave. See, this your amplitude of the carrier wave is varied with respect to instantaneous value of the message signal with respect to carrier amplitude. Can you see here? This is the carrier amplitude. See here. Can you see here? See, your waveform is now varied with respect to this. Can you see here? The carrier is varied with respect to this reference. Can you see here? This is the AC. But this is also AM wave, but this has a carrier component in this. Can you see here? And you see it is varying with respect to this. So because of this term, using AC, using amplitude AC, we can control this amplitude, yes or no? Right? So what is that parameter which controls AC? M. Right? See here, you have M. Can you see here M? What is this M? M is equal to Vm by AC by AM by AC. Yes or no? So you can have different AM and AC, and you can control M. Yes or no? Right. So that means you can control AC. Denominator you can just make it high and low. AM is not in your control, is it not? Only AC is in your control. So AC is going to vary and M you can vary. Have you understood this? Right. So M is equal to AM by AC. From this equation you already know it. Okay. Now if you want to control M, if you want to change M, okay, you have to change your AC. That is amplitude of the carrier wave. Have you understood this? Okay. That means in this waveform, it is possible to change the shape of this by varying AC. What happens if I vary AC in this particular waveform? This will come closer and further. Yes or no? This will come closer and further. Yes or no? If I vary AC, right? Now we don't say we are varying AC, but what we say we are varying M, and that M is called as modulation index. Have you understood this? Okay. So if you vary modulation index, okay, this gap will vary. This gap will vary. Why? How this gap will vary? Because your M is equal to AM by AC. And if you want to vary m, you have to vary the carrier amplitude. This amplitude you have to vary. I've understood this. So why I'm telling you, because the importance of modulation index, okay, comes into picture from this, right? If modulation index is greater than 1, what is the meaning of that? If the modulation index is greater than 1, what is the meaning of that? Right? Your AC is less than AM. Right? What will happen when AC is less than AM? This will come down, right? This will overlap. This particular waveform will overlap on this. This will overlap on this. That is called as overmodulation. Overmodulation. You should completely avoid that. Why? You can't recover the signal, right? Your peak will be gone, right? If you do that, that's why modulation index will be always less than 1. Have understood this? Okay? Less than 1, not less than equal to 1. It is less than 1. Okay. Now, the waveform which you see is the waveform of conventional AM wave. Is the waveform of conventional AM wave. Okay. Now, let us define one. You already know modulation index. Modulation index is AM by AC. Right. Now, from this waveform, let us define certain parameter. See, this is AC, amplitude of the carrier wave, right? Okay. What is AM? This is AM, yes or no? Right? This is AM. This distance is AM. This is AC. This is AM. I've understood this. Now, let us define a parameter called as, okay, A max and A minimum. Okay. Let us define a parameter called as A max and A minimum. See, distance from here to here, okay, you make it as, you write it in terms of A max, okay, and this distance we make it as A minimum, right? Now see here, this is A max. From here to here is A max, okay. From here to here is A max. Try to understand this. From here to here is A minimum. This is A minimum. Okay. Now, what is the distance from here to here? 2 times A max. What is the distance from here to here? 2 times A minimum. I understood this. Okay. See here. Try to understand this. See, this distance is A minimum. Fine. This distance is A max. Please keep it in mind. Here I am using every amplitude as A. Need not be compulsory A. It can be V also. Right? Have you understood this? Okay. I am here using it as A. Amplitude I am taking as A. Instead of all A's here, all A's can be replaced by V also from your side. Doesn't matter. Okay. Now can you write this A max and A minimum in terms of AM and AC? Right. Now see here. Here to here it is AC. Yes or no? Here to here it is AM. Now what is AC plus AM? What is AC plus AM? AC plus AM is equal to A max. You have that one equation there. Okay. I understood this. Okay. Now, you can have one more equation. What is A minimum? Right? Okay. So you can write 2AM is equal to A max minus A minimum. Yes or no? From this equation, from this figure. Similarly, AM you can get it from here. AM you got. Similarly, AC is equal to A max minus AM. Right? This AC is equal to A max minus AM. Now you got AC here. AM already you have here. Substitute here. Okay. Now M is equal to AM by AC. You have AM equation here. You have AC equation here. So what is it? Finally, for modulation index, M is equal to A max minus A minimum divided by A max plus A minimum. How do you get that equation? M is equal to A max minus A minimum divided by A max plus A minimum. It is because of this just distance. Go through this, glance on this, then you derive it yourself once again. It is very clear. Fine, okay.